journal we had to do for the field experience. For the field experience.
Yeah.
Remember where he was like, okay, you need to have more observations than this. I said, I feel very stuck to because how am I supposed to remember back? And I got so angry about that because I felt like their observations, how are they wrong?
I know.
You know what I mean? Like observation should be like a pass fail, like reflection, nothing enough, like
And we're missing
like you could be looking for certain things in your observations, not just like good. But as long as like it looks like they were actually there and they did it. That is. So I like got angry about that.
I was like, she was so
What? I just don't think.
well, she said you Snapchat, so I'm like, yeah, it was pretty bad.
And then
know.
you say content, but because he's really not so
Just
good.
for real.
Because he's black. Black
It wasn't what we left.
And that
But when you
irritates
got
me more.
when you left, it was bad. It was rain. It was a beautiful walk every day. It was.
And I also feel like he thinks hot as we wrong. You know what I mean?
You guys should fight.
Oh, square up. We'll just square up. I'll meet you at 2:55 on the dot. It's just. I'm like done.
No, you have to.
I swear on that, I'm not going to do that at all.
Oh, hold on,
I will
no.
keep my mouth shut in their class and go on Pinterest.
I don't either.
Because Pinterest is like, yeah.
Literally.
No, I really don't have any other classes that I remember. I love all of my other classes, like so much.
I'm not tired.
And that class, I just gotta get one chair. But it's like I have one more class before I get the certificate, so it's like I have to push through.
I don't want to take my kids to school early. I don't want to stay here late.
But it's just really hard. I feel like there's
You have time today?
Yeah.
Did you pick?
And my,
I feel like it turned out pretty
my
good.
week,
My week, I checked Josh's. This is really different. I sent it last night.
It was so like.
I lost that one.
No, I
I want to see those.
Let me send it to you. I checked, I wonder if I just feel like they have mutual respect. Like, you want respect. But like his is no like.
Maybe you want to.
100%. Remember the first day last year? We all talked about my teachers. He's like,
Well,
yeah, he's like, that. I was like, and I was just like, do it.
Because
everything said,
like my family's a teacher.
And he's like, yeah, don't say that.
Because he asked us, he was like, what is your,
Yes.
why? And like people are just telling him. He's like, you
Don't say that.
It's like, well, that's the reason.
He literally said that straight up. You may have dropped it by then though, because it was one of his like icebreakers. And he asked us why we wanted to be teachers, and he was like, we all say like, you have like parents who are teachers, you love kids, like all of the stuff, and he's like, don't say that.
So I gotta go.
I can't, but I'm so close to finishing the certificate. But I'm not even getting the 4.5, so like for me, it is worth it.
I know.
Not for what I'd be like, if I were getting the 4.5, I'd be out of there.
So like one day they'll be like not right now, and then the next day they're like
He's so
In
really
little spots.
It's just flat out rudeness, and he like, but he thinks that I'm rude for like confronting him about that. Like I don't say like flat out you're rude, but I'll be like, okay, but this is what you said, and this is what you're telling me now. So I'm confused, and he's like, who is this person? The ESL, the certificate teacher. So literally like,
everyone hates him.
he's so rude. He has to be the smartest human in the room.
Oh, 40.
And like, if you like describe your point of view on something and it conflicts with his, he's like, no. And it's just so irritating. Karen, this is your class. No, I'm asking you. Well, it's all you. Enjoy. Enjoy your class. I don't even.
We talked about addition being or subtraction being the inverse of addition last time? Remember that? And how did we get the students to figure that out for themselves? Do you remember? Lord.
Isn't that through like using the manipulatives, like, okay, like show them addition, but then use like a subtraction problem with the manipulatives and show like how that works, like.
Yeah.
I
Okay.
gave you, she had 2 choices, I gave her 3 choices, how many does she have? Okay, now I took away 1 toy, now how many does she have?
Okay. Yeah, very good. That we basically what when we first introduced subtraction, we're doing it with manipulatives. And at that point, we wouldn't do it. When we first introduced subtraction, we were trying to introduce the concept and get them to write it. But after, it wouldn't take very long, especially certainly by the first grade, because we aren't going to teach the subtraction facts as a set of facts like we did with the addition facts. We had all those different strategies for all the addition facts, like adding 0, adding 1. So the subtraction facts, we're trying to marry them to the addition facts in the student's mind to see that they go together. But we need the students to see that they go together. So maybe we're doing a subtraction problem like 8 minus 3, and the students, now they know the minus sign, they know what this means, and then they take this, they do this with manipulatives. So we want to make sure we're using manipulatives at this point. Okay? So they have 8 objects that take away 3, and they're left with 5, and so on their desk they have 1, 2, 3, 1, 2, 3, 4, 5, so that's what's on their desk. And now you can ask them, okay, I see 3 and 5, if I bring those together, what do I get? 8. All right. How would I write that? Okay. They should know the commutative law, they don't know the name. But if I switch these, can I, what would happen if I did the 5 first and then the 3? Okay, so we get that. So I'm going to write my data on the board. And I want to go back to subtraction. Hopefully this has happened before this day, where the students are noting, and you had a lesson where they're noting that 8 minus 3 is 5 and 8 minus 5 is 3. But could you see that that'd be an easy way to link those two if they took away 3 and they got 5, and then you said, okay, let's put them back together. 8, now take away 5, what do you get? 3. And then you go ahead and write those both on the board. And you collect your data. Too much fun out there. This is a no fun zone. Okay, so they know that these 8 minus 3 is 5 and 8 minus 5 is 3. They discovered that prior because we've done several problems where we put them on with pairs and they say, oh, the same numbers all the time. Okay? Just like we did with 5 plus 3 and 3 plus 5. So now we're just bringing them together. Okay, we're trying to, at this point, what this lesson's about is attaching the subtraction facts to the addition facts. Because we want them to use the addition facts to figure out the subtraction facts. Okay? So far, so good? All right, so we bring them together. We talked about this last time. We're going to get these problems and write them on the board, write several of them. Okay, I'm linking the subtraction with the addition. And now I could ask the students, how can I use addition to solve a subtraction problem? Such as 15 minus 6. Okay? Now here we are in first grade. They might know the basic facts of addition right now. They might not. Okay? And so basically, after you've just had a lesson, or in the same lesson where you've just done this, I'd let the students just kind of think about that. They are going to have great communication skills. Although we saw a lot of really good communication in some of the videos we've been seeing. okay? So they'd say 6 plus something equals 15, and you know that 6 plus 9 is 15. Maybe we just learned that fact, by the way, you know, learning the nines, okay? So now they have a way, they're thinking that, okay, I can use these addition facts to do my subtraction facts, and then that's what you're going to emphasize from now on. So if they say, well, I could say 6 plus 9 is 15, so that can help me, so I'm going to put 6 plus 9 equals 15, okay? And that's the way I'm going to set up a worksheet, okay? Where I'm going to have 15 minus 6 equals blank, and then underneath it's going to be a blank or a blank with an addition and equals, whatever you want to do, something like that. Underneath this here, and I'm going to have them just kind of work on that skill. And so you notice, by the way, again, we're going from concrete to abstract. When we get the information on the board, that's when we start to look for patterns, okay? And at that point, and that's where we're at right now, that's when we could do the skills, the decontextualize, the worksheets. That's when the worksheets come in. Okay, it's after the context, which is the manipulatives. It's after the higher levels of blooms. You know, they're analyzing, they're creating some kind of a rule. They found a pattern. So you kind of see where the decontextualize. So that memorization, that worksheet part does come into play. It just comes in later. It's just the opposite of the way we think about math, particularly when we start to get in the second, third, and fourth grade. We think of it as math being the skills, let's do a whole bunch of these worksheets, and then we start to try and contextualize it with word problems, and then that's where it falls apart because they don't know what all these skills mean. So you're avoiding that because you're going through word problems to get to the skill. Okay, so you're going through manipulatives, hands-on stuff, it makes sense, and then you're coming up here and you're getting to this point here. Does that make sense? And that, in general, is a way that you know you want to teach. And so this again, it's just, you see, I keep referring to that board over there because it just drives everything. And of course, remember, that's what the students understand. They know the language, they know concrete stuff, they understand things on their desk. They don't understand this until they understand that stuff there. Okay? There was one time, just to kind of reinforce that, and what we kind of have done in math in the past is, I had a nephew who was in second grade. I asked him I wanted to see so I wanted him to convert exponential notation, which is what you see up there, to a regular number. Okay? And so I'm talking about, I said, now here's how you do it. I said, you look at that little number up here, and then you look at the little period, because that's all he knows, he's in second grade. Look at the period, and whatever that number is, you go 1, 2, and then you write. And he didn't know decimals either. I said, here, let me show you. Now, this is a very traditional lesson I'm giving him, right? It's all skills-based. He doesn't know what any of these numbers mean. The little number, that's why I have to use language like the period and I don't say exponent, okay? I say the little number up here, okay? He doesn't know what that 10's doing there or anything. And so I said, okay, here, let me show you another one. He said, no, I got it. And he went down and he did all the other problems correctly. All right. Now that, in a nutshell, is the way we've been teaching math for like 150, 200 years. We teach that, like he can do that skill. Does that mean we should be teaching second graders this? Okay. I mean, he could do it, and that's what a lot of math has turned into, where it's just getting our students to do things like that so they can pass the test without any means. That's not the goal. The goal is for them to understand what it means and how to use it. Okay? So that was just a real, just a quick example of traditional math in a nutshell, what traditional math has been And the results is that he couldn't use anything like that. And that's the way probably most of us feel, especially beginning with 5th, 6th, 7th grade math and beyond. We probably kind of feel like, what is this for? You know, with algebraic equations and things like that, the quadratic formula and the trig and sine and so on. You know, all those things, like what are they for? Well, it's because we learned them the way I just showed you here. Now, I gave him a problem, a word problem or a situation that involved this. He couldn't solve that. He wouldn't be able to understand it. Okay, so if I said like there are 16.834 times 10 to the 5th, or even times 10 to the 5th number of stars in the Milky Way galaxy, and how many total stars are there? He'd probably look at, probably if he would solve it, he'd do like most of us. He would say, okay, I don't know what any of this means, but I'm going to look for a number like this. See, I'm not understanding anything. I'm just going to look for a number like this, and if I see it, oh good, I know what to do. Yet he doesn't comprehend anything in the problem. Matter of fact, I could put a bunch of gobbledygook, even in this class. Right now, if I handed out a bunch of gobbledygook, and I had this, if I had 3 problems like this after showing you this, and if you couldn't decipher it, you would know what to do. Okay? And that's the way we've traditionally taught math. Okay, so that kind of is like saying, okay, then how should we teach math? And that gets back to over here where, you know, they should understand the thing first. It should be in a context, concrete, especially for this age group, or pictures. That's what all this is about. So they can figure it out, higher levels, and again, the patterns. That's what's coming out. They see patterns and they see that math makes sense. Okay? All right, so that's kind of looking backwards, since we've come here, we're in week 6 now, and kind of looking backwards at what we've done and what all that meant, because I gave that to you, a lot of that in the early part, and I've been trying to emphasize it as we've done it like I did today with this here. I try and emphasize it, but it takes a little time to kind of put it all together. So now I believe you're at a point where you can start putting it together and saying, oh, I see now really why we're doing this, why this is so important. Okay? Now, what we have up here, get back to this group here and this group here, those are each called fact families. Okay? So this is a fact family, this is a fact family. If you know one of those facts, you know all 4 of them. And so that's why we're putting them together as families. So, and remember the students are learning the addition fact family, or I'm sorry, the addition, so they might learn the 5 plus 3 is 8, and then when they see 3 plus 5, they say, okay, I can switch that because I know I can switch those. So I don't know what 3 plus 5 is, but I know what 5 plus 3 is, and I can do that. And now we're attaching all that information to this here. Use the same digits, the same numbers, and you can do subtraction now too. It's called a fact family. Now for some of the tougher fact families, we're going to make some cards for those. Now, do you still have your index cards from last time? Anyone need an index card? Anybody else? You will need a pair of scissors, so if you need to get a pair of scissors from the blue box, I can go ahead and get those right now. I'm going to give everybody 2 of these, so we can take a couple of them.
Hi, Steph.
Blocking your way. All have your card there. What I want you to do is lift it up like this here, and then have the ends meet in the middle of the card, and make what really amounts to is 2 doors. Who took my grown-up scissors? I gotta use them. No, I'm just kidding.
Who does she think she is?
I know, you really,
Right?
I'm not a lot of cold medicine.
This is why you're the professor has a problem giving.
Are you ready to use the adult scissors
Oh,
yet?
I know, right? Yeah, there are little rounded, so
Oh.
they're safe and stuff.
Okay, you see I draw a line, I drew a line up. You don't have to draw a line up there. I just drew one up there because that's where I'm going to cut. I'm going to cut along this line and then cut along the crease up and just take this rectangle out and this rectangle out. Okay? You're careful, Lauren.
So you see the line?
Yeah, I could write it your best. Or not.
Sure you're ready to solo?
That's gonna be half the battle. Yeah.
Cut them all the way off. We're not going to use those. I probably could have given myself a little bit more room on those when I cut off.
You're giving us anxiety. How many lines are you cutting?
So you want us to cut more off and just?
Yeah, a little more. You'll see why. You'll know what you want to do then after I. Okay, so what's a hard math fact that you think students, like addition fact? You okay, Kayla?
We're cutting more out?
You can, if you want, you don't have to, but when you see what I'm gonna do here, you'll be able to judge for yourself. Okay?
I'm trusting you on this, buddy.
Okay, what's a hard math fact? 9 plus 7. Okay, so let's say that's going to be the fact family we're gonna work on. 9 plus 7 equals 16. Okay, so that's what this card is gonna be about. So my students have trouble adding 9 and 7 together. Okay? So what I'm going to do is put 16 at the top. And on the left, I'm going to put, behind the left door, I will put like 9 dots. I could even put the number 9.
I got all these markers over here.
And then under the right door, I'm going to put 7 dots.
I'm gonna do that in the shape of our choosing.
You can, and I was going to say this a little bit later, but you can also do this like if you're teaching shapes, like parallelograms. And that's a very nice way to put those in there. Okay? Alright, so now I've got the fact family 9, 7, and 16. And so what I can do, what students can do with this card is, they can open one door, 7, and say, okay, what's the addition fact for what plus 7 gives me 16? Or 7 plus what gives me 16? And they guess 9, we open it up and it's 9. Or vice versa. Open up the other door, 9 plus what is 16? Also the subtraction facts. 16 take away 9 is what? 7. So you have all 4 fact families, or all 4 of that fact family in there. Okay, so you use those for the tougher ones, and then those are kinds of flashcards you can send home with the students, but you are, again, giving them, reinforcing the idea that if you know 1, you know 4. Okay? They're all related. All right? So let's just do one more. So I'm going to do what you just said, Lauren. I'm going to have the students draw in shapes that they're learning. So, for example, a parallelogram, okay, or a rhombus. So maybe they just learned the rhombus today. By the way, if you didn't learn that in kindergarten, first grade, that's the new thing now. They're starting to teach rhombus and parallelogram at a very young age. I remember I didn't learn them. I don't think until 5th, 6th, 7th grade, somewhere in there. What's that? Yeah, it's right there in the standards. Okay? So if you're going to teach, like for example, a rhombus, then I can make the shapes and have them draw the shapes in there. Instead of the dots. I'll make 6 and 8. And if there's something that, even another content area that you're working on. Okay,
you just drew the shapes to kind of connect. You're just using the shapes as something else that they were learning, right?
Yeah.
Okay. I didn't know if the rhombus actually had to do anything with number 14, so.
Oh, yeah, no, it doesn't. What I'd say, right now I'm just showing you something that you can use, instead of using dots, you can use something else that they're learning, like in this case a rhombus. And it could be something, I'm not sure, I'm no expert in science and social studies and history, but if they were learning some kind of like vocabulary or something like that, they could put, that on there. I mean, if you had stickers, like if they're learning George Washington, for example, you had little stickers of Washington, then you'd hand those out. Anything like that you could just use, it just double dips, so to speak, on this idea, okay? All right, we're ready for our video. She's going to actually show you in here. She's going to talk about subitizing. And by the way I drew these, it's sort of are subitized, but not. I mean, I guess you could look at 8 being that way. It's the standard way to see the number 8. But you could have made like the numbers like,
1, 2, 3, 4, 5, 6, 7, 8, like that, 2 rows.
Yeah, you could have made them in terms of rows. You could have used a mini base 10, or what's not base 10, a 10 frame, a mini 10 frame here, and have them, just kind of course the subitizing. So she's going to talk about that in here too. So talk about the decade numbers, 10, 20, 30, 40, and how to build off of those decade numbers. So 40, 41, 42, okay, the counting on. So a lot of the things we talked about, she's using in this classroom here.
My name is Jeannie Wright. Come with me as my first graders find the mathematical reasoning of letter contracts. Now listen up, because yesterday was the 125th day of school. Well, I guess it was Friday. Today's lesson was our typical math routine. The kids come to the carpet. There are a couple of things that we've done since the beginning of the year. The guess my number, mental math, some strategies with 10 frames and double 10 frames. So it was sort of a review. What's our mystery number today?
33.
And what's one more?
34.
What's one less?
32.
Man, I was trying to trick him because I asked him in a different order this time. How many is my next friendly number?
7.
How did you know that so fast?
3 and 7 is 10.
Oh, 3 and 7 is 10. Do you? Now wait a second. What's my next friendly number going to be?
40.
Oh, how did you know that?
It goes 3, 4.
Oh, and then if you were using that with tens, it would go 30 and then 40. Oh, look at you looking at the patterns. Good job. There are just certain benchmarks, the friendly numbers, the decade numbers. They're supposed to be able to get to those because then they're able to do mental math quicker. All right, well, let's see if you could do that one. Justin.
31.
31. How'd you get 31?
Because I took away 5 from the 6, then I made a 30, then I just had 1 left, then I made 31.
Okay, so let me get this straight. You told me that you took the 5 from the 6, and what does that do?
It makes the 30.
It makes 30 because you've added it to that 25. And then how many do you have left over from that 6 then?
1.
Okay, 1. And then when you add that 30 and that 1, you're gonna get?
31.
Excellent. It is definitely good news when the kids see patterns because they pick up on things that I wouldn't necessarily see.
I heard Demetria said that's 30, and then 24 plus 1 is 25, and then you add 1 more from the 24, and then it's going to be 1 more from the 30.
Give me a high five, girl. Let me tell you, I didn't even notice that. When I made those problems, I didn't even notice that. And here you see these patterns on these with these numbers. You are amazing. I had 26 plus 4, but then the kid said, well, 26 plus 5. We had already solved 26 plus 4, and the kid was like, but that's 1 more, and that's how I saw it. And I thought, oh my goodness, I didn't even see that. Because I'm just so into trying to get them to use their strategies, they notice the patterns. How would you solve that one? Miss Gianna, how did you do it?
I know at 6 and 4 make 10, and if you add 6 more, it would make 16.
Oh my goodness. It's very thoughtful. The addition problems that I used were a review, and they're also looking to where we're going. I am moving to a part whole here. What's my whole thing? Okay, Mr. Pierce, what's my whole thing?
A 12.
A 12 is my whole thing. What do you see?
A 6.
I see a 6. Now think about that. 6 and what? Because I have my hand on it, I'm covering it up. 6 and what will give me that 12?
6.
How do you know that?
Because 6 plus 6 equals 12.
It's really one of the most difficult things for first graders to understand is the missing addend. It's algebra. And how do we know that 6 and 6 make 12? Justin?
Because you have to add 1 to, you have to take away 1 from the 5 and take away another 1 from the 5. Then you have 2.
Okay, so let me get this straight. You're saying take 1 away to make this
5.
5. And then you're saying add another 5. And that would give you what? 5 and 5 make
10.
And then you're saying add 2 more?
12.
Yeah, I know. These kids are able to see you're solving for what's missing. So there'll be the kids that see the 5 and the 1. There'll be the ones that see 2, 2, and then 2 more. It's just how they see the dots. All right, so I have a situational story for you. I need your help to solve a problem. All right, can I count on you? All right, our family leprechaun projects are due. In first grade, we tried to be very creative. The month of March, their family homework project was to come up with a leprechaun trap. Who doesn't want to catch a leprechaun and come up with a pot of gold? But I can't just shove them all into a room. I need them in containers. So I thought the kids could come up with how many containers would I have to go to Target to buy to house the 30 leprechaun traps? Now, each container must have the same number of traps. So how many containers should I buy at Target? I want you to find 2 different ways. This lesson wasn't about division. This lesson was about addition. What are the different number combinations to 30 that would make them in equal groups? So the kids who see 3 groups of 10, the kids who see 6 groups of 5, everybody could see 30, but everybody's thought a different way. How would you have 3 tens?
If you have 10 and 10, it equals 20. If you have 10 and 10, it equals 20. And then 10 more equals 30.
Okay, so if you had, but now think about this, how many containers would that be?
There would be 3 containers.
Okay, so if I had 3 containers, and you're saying,
One 10 and one, another 10 and another, and then one other one.
okay, so that's one way. Can we think of another way?
I was thinking of something to count like by 2s.
Oh, okay, counting by 2s.
2, 4.
The number 30 was chosen because there are so many different ways to be able to make the number. We didn't come up with just one solution. I want them to explore. I want them to see that there's more than one way.
Like I counted by 2s because first I was doing it like in groups of 6 or something, but then I said, I don't think we have enough cubes for that.
Okay.
So I don't know how it could do 5, but maybe we could try doing 2s. And so I did 2, 4, 6, 8.
It's definitely all about mathematical reasoning. With Common Core, they just need to be immersed in it. But now they're really using it as a strategy. And I'm hearing what strategies, and it's not just, well, I counted and it's in my head. No, they can mathematically reason how they get to answers. There's another way. Juliana?
It's like on a dice.
It's like on a dice, so I know that there's 5. So we have 5, 10.
50.
When I was a youngster, we used to play games that had dice in them. So you just knew what a 5 looked like. It's subitizing. Like they don't have to count each dot to know that it's 5. They just know the formation. They know that it's 5, and then the next number would be 6. It's just looking at numbers, the patterns that they see in them. Okay, so she had these like this. And then what did you do? She had 6 in one, and she had 4 in the other. Kaylee came across a problem where she had broken the group of 10 into a 6 and a 4. But without any prompting, she could see that the groups then weren't the same, and she was able to move them around so that they were. And why do you think she did that? What was so important about this lesson and about doing that? Gabriella?
It has to be the same amount.
Okay.
But she had that one the biggest, but she could have took only one off that one and left that one.
She discovered that 6 groups of 5 would still use the 30 traps. So, what did you do?
I put 2 3s in each basket, so you would only need 5 baskets.
Okay, so Jean Marie was over there with Alexa, and remember I told you she had 10 piles of 3? So what did you just say? You thought that you would take 2 piles of 3
And put them in one basket.
and put them in one basket. So she did 6. Look at this. She was the only one that had groups of 6. And so when I asked her about it, she said, well, I was working with the group and they had groups of 3 and I just put the 2 groups of 3 together. And I thought, oh my goodness, I would have never known that had I not asked her what it was that she was doing. You know what? If I'm thinking about which ones I'm going to have to buy, am I going to buy 10 containers? Am I going to buy 3 containers? Am I going to buy 15 containers? What do you think my best choice would be? And you got to tell me why.
I think you should buy 3 containers because it's the cheapest way.
She's relating it to money. She's seeing that there is math even beyond our classroom. I just want them to see that there are patterns, and we're going to take a journey all year long on why do those things work that way.
They're containers, and each one must cost the same amount of money, and like something plus something equals like something, and like if it's a big number, it would equal an even bigger number, and I was thinking that everyone one wants to save money.
Okay. Is that a can we put that on our test?
Yeah, something plus something.
Something plus something.
Something divided by a fraction equals something else. I'm just saying. Just saying. That was being like cute as hell.
Okay.
Good way to end the video. And everyone likes that was just how it.
First graders doing some pretty impressive things. What did you notice from our class? You know, because now you are, you know, you're a professional, like someone watching, you know, like a parent watching, they wouldn't see some of the pedagogy that we talked about in here. What did you see that was happening there that we've talked about? Yes?
I saw the one where it was 6 plus 6 plus 4, when I looked at it, I was thinking of 6 plus 6 first, but then the way she did it was easier because anything added to 10 is just whatever it was, so it was like, I don't remember what the number was, it 16 or?
Yeah.
But I thought it was so much smarter than what I was thinking of this, so I guess there's things that I don't see that they did
Yeah.
right away, which is pretty cool.
And we were kind of brought up that way to look at it, do it from left to right. Is that what you're going to say?
That's exactly what I
Oh,
was
I'm
gonna
sorry. Well, go ahead, you explain it.
No, like just how she like I would have started and then I would just count on my fingers.
Okay.
You know, but when I'm watching the video, I'm sitting here like, wow, that was I didn't get that yet. Hold on, you know, like so. I guess when you teach the kids to think a certain way, like differently than you thought, you know, instead of having the negative connotation of Common Core sucks and it's this and it's that because everyone hates it, you know, like there's just a different way to learn, and I guess that's good because everyone learns differently, and maybe there was a kid who did it just like me and Shane were gonna do it, and got the same answer. They just, you know, took 2 seconds later to get it. So does that mean they were wrong?
Yeah, no,
So-
obviously. And then by them sharing it, that's why you can listen and say, oh, you know, that would make more sense to me. Okay, but see, now we're confined because we were taught you have to do it this way. Okay, and they've obviously been open to explore however they want to do it and share it. Yes?
I like how it kind of showed how understanding it, math in a context and like that concept can help like bring them to a new level because they were doing multiplication like in,
Yeah.
you know, 10 groups of 3 and they didn't really have a word for it or didn't really, they saw it as repeated addition,
Yeah.
but because it was in a context and it wasn't just like, okay, it's repeated addition, so you go 3 plus 3 plus 6 and so on and so forth, like they were putting it in some sort of real life situation. and
Yeah,
solving
they could
problems.
relate to.
Yeah.
Yeah, they could very much relate to. Okay, what else did you see? Yes?
With it was essentially what we had, but the 6 plus 6, the one little boy who said, well, if you do 5 and 5 and then add one more to each, in my head, that's a lot harder since like
Yeah.
the one kid before just said 6 plus 6, but if that's how he understands it, I find that quite interesting.
Yeah, he must like to count maybe by 5s, maybe
Because he did that,
prefers.
the previous problem with the,
Yeah, 6 plus
20
6 plus 4 or something.
well, the
No, that was
25 plus 6, he
Yeah.
said you do the 5 and then you have the one left over, which that would make actual like sense to me, but the do the 5 and 5 and then add the ones was a little different, but.
Yeah, and if you're like me, when I find a method of solution, I kind of stick to it. I don't like explore so much. He might have been doing it, I might say, okay, I get that, I'm gonna keep applying that, even though it's harder, and so if he listens to somebody else, he might say, oh, you know, that makes sense to me too. So that's what the importance of those discussions. Okay, what else did you see in there?
The teacher wasn't giving them the answers, of course, at all. She just kept asking them, well, why do you think that, or why did you do that, or, you know, so instead of telling them, oh, you did it wrong, or you didn't do it that way, and then I think sometimes even when she thought that they were not doing it the right way, they showed her why they did it that way, which turned out like she didn't even think about it that way.
Yeah, yeah, and that's really important because, like the one with the 3s and the 3s, and they put them together and got the 6s. Yeah, she wasn't even thinking about that. So if she were trying to explain what the student did to the rest of the class, she would have messed up. That isn't what the student did, and maybe the rest of the class wouldn't have understood that. So she's basically drawing out their ways of thinking. You know, just like Troy, what she said with the 5 + 5 + 2. I mean, she's just drawing them out and they're just listening to them and sharing them, and if it makes sense, they might use them. Okay, some other things that I noted was, she talked about this, and there's just so many connections in math that we don't see them, and I didn't see this until she started mentioning it, but this is a part-whole problem. In other words, those things are already there, and I got 2 parts. And she's also talking about the missing add-in, which are the first 2 numbers, like 3 + 4, okay? And how those are very, very difficult for students to solve. Like, for example, this one, what is it? 1, 2, 3, 4, 5, 6. 6 + what is 14? That's a very difficult problem for students to solve. Even more difficult is what plus 8, or 7, whatever is there, 8. What plus 8 is 14, where the first number isn't known. Especially in the written, in the abstract. That's easy, or easier than, which is easier than. So these get progressively harder for the students. So it's like here, okay, I've got everything I'm beginning with, and I can do this problem. It's like 9, and I got to start balancing things, okay? And if I don't know subtraction yet, I got to start thinking, okay, so I'm thinking addition, and so that's very difficult. But at least I'm starting with 9. Here, they're starting with nothing. That's the question. That's very difficult for them to understand. Okay, so she's talking about this missing add-in, which are these 2 problems here, and the way that you could introduce problems like that is through something like this, where they're working with this thing here, and then suddenly you say, okay, so what plus, obviously they don't know subtraction. I think it sounded like they didn't know subtraction. So let's just start with the easier one. What's that, 6? 6 plus what is 14? As they start working with these, it's semi-concrete, by the way, it's semi-concrete. They can have manipulatives there to help them. Okay, so they can make 14 over here, they can make 6 over here and try and figure it out. Okay, but once they get the hang of what this is, now we're ready to go to the abstract, and I could write 6 plus blank equals 14. And then ask them again, what is that? Oh, it's 8. Okay, so now they start to interpret again. See how you have to always interpret this? That's why we do the abstract last. You always have to look at it and you have to interpret what it's saying. It's much more easy to look at something like this and say, okay, I know what it is, and even easier with blocks. So if I have blocks and if I had like on the document camera 6 blocks, and I had some other blocks under here under a card where they couldn't see it, and I'd say, what do you think, but I know the total's 14, what do you think, how many blocks do you think I have under there? Okay, so I could do something like that. All right, but again, yeah, we're seeing all this. We saw concrete and semi-concrete. We saw with manipulatives. When they solved that, when they solved the word problem, that was with manipulatives. Let's see, we saw the missing add-in, which we hadn't talked about that. We saw the progression. So when they did the manipulatives for the boxes, then they went to a drawing, because then they were discussing it though with drawings. Okay, what they were doing with those blocks, that's concrete to semi-concrete. In other words, it's a little bit abstract, semi-concrete, because now those represent real things. Okay, and then finally you get to the numbers, which is the most abstract. Okay, which you really can't tell what. You know, this doesn't look like 9 blocks at all. It's just the number 9. Whereas if I draw the blocks, okay, they sort of look like it. So that's a semi-concrete. And if I have the blocks, they're there. That's it. That's what I'm talking about, okay? And let's see. Okay, let's talk about that. All right, any other questions or comments about the students? Or, I mean, the video. They're pretty articulate. They could say some pretty good explanations. And I was really impressed with that. Yeah. Well, I mean, and when she said something plus something equals something, she is going very abstract because she's seeing she worked with actual numbers, whatever it was, 3 plus 5 plus 7, and she's starting to see that, oh, well then in general, those are variables. X plus Y plus Z equals A. She just isn't saying X, she's just saying something. And that's what a variable is, it's just saying, it's just something. We don't know what that something is. So she's actually doing algebra right there. That is real algebra. Okay? And that's that kind of gives us the power of the a first grader's mind, because we wouldn't think, oh, no, they can't do that kind of stuff. They couldn't come up with these different ways of solving the problem. How could they do it? They're only in first grade. They can't problem solve like that thing with the number of boxes they would need. How could they do that? And they went ahead and they did it. They're a lot more intelligent than we give them credit for. Okay, how about we get back at 11:15, and then we will look at the Khan Academy, the pros and the cons. Khan Academy. Oh, that's a door.
No, I feel like, did you do like I did the chopper?
Oh, yeah, let's just like.
But I
think so. So I Googled this. I
don't know if that was.
Door there, a window.
That was.
I did a speaking scale and a writing. So I started and I had them like after we read it, and over the meeting, I was like, so I said maybe how I would like present maybe the theme characters and maybe like in the story. So like thoughts, picture, use contextual examples as well as real life examples. And then I said after that, I would ask the students to, if anything, answer prompts about the story. So they would write that in their dialogue journal, and then after I was gonna have them like pair up and retell the story as just like spontaneous retell. Just for speaking.
Yeah.
With each other.
Yeah,
And then I would give various prompts or like directions as needed for each student.
yeah, I mean,
So if, like, maybe they get stuck on like the gingerbread man because of like, okay, he ran away from home, and then they don't know what to do. I'd say like, and then who did they meet?
for the writing.
Yeah, and I said that I would like expect it to be in like short formulaic sentences. I finished like that whole like instructional strategy. You just have to do like
Sign on to.
or
Did you?
there's new sign out.
Well, what did you put for like the level? Because how do you
I
say
did
that
level
there
1
is-
freshman.
Okay, because it's such a basic book and they're like older, you know what I'm saying? So.
That's what I was thinking. I feel like that's a unfair thing for him to do, cause like, if the patterns across all levels are the same, like a level 1 is gonna have very limited vocabulary, like, that book could still be hard for them, even though it's considered a children's book. But I figure for like retelling, it's actually a good book because like, I never wanna go to this class, I have to. How's his class? But
I was surprised you didn't pick. Not
I-
because you said you were going to skip.
well, I didn't just skip to skip, I was, okay, and I went to the doctor.
Was that Monday?
Yeah, like I called off my next 2 classes and went to the doctor. And they were like, well, it's just a virus. I thought I had the flu. Cause it went on for like 5 days. I just didn't respond. Cause he acts so nice and like in text. Like he's so rude to me in person. To tell me it's a new. That's hysterical. Okay, feel better. That honestly is so. I still have to do my application. Oh, for. Yeah. When does that do? March 1st.
Oh, we've got plenty of
I
time.
have to answer like a few questions that are like kind of bad, which I didn't
No,
expect that.
you just literally fill in the blanks to the
No, there's
legally blocked.
questions, like what does it mean to be like an effective teacher? Do you
Yeah.
like use prior?
What?
Basically explain your philosophy of
Right,
life, your
yeah,
background
bro.
experiences that have brought
Yeah, I
you
was
to
expecting
this.
that. So
Yeah, it's pretty in depth.
See, I don't feel like that's that bad.
Well, some of us don't have our lives planned out already.
Yeah.
Right?
No,
My,
it's
my,
not
I
planned
just don't
out.
like being so touchy.
My day is
like,
not
why are
planned
you
out.
so like personal?
Yeah.
and then you have to
Because you're like, it's someone whose classroom you're taking over, so they wanna make sure your philosophy and your whole like ideologies match.
What
and,
goals
like,
and or
match.
expectations have you established for your political practice experience to be specific and include your skills and knowledge applicable, thank you, and my interpreter, to clinical practice, teaching techniques, methods you have had some experience with, and with, I feel like you, I guess if they are sitting next to a different teacher, but still. But then it goes
Just
on.
Plan to write like 4 to 5 good sentences about each thing and you'll be fine. It's
But
not
I
very
already
great
requested,
knowledge,
I already
you're a
requested,
teacher.
we requested me,
I mean,
You'll be fine.
You're never gonna correct this so bad.
Yeah.
Where's Tony?
How rude. Do you own a Harley? No, just curious.
You trying to fill in space while we're waiting for Tony?
Yeah. Classical music? We just wanna know who you are, Dr. Christie.
Suddenly you have this need, why are you gonna put it down in your application?
She's gonna use that because she knows you're a successful teacher, so she's
Yes.
going to use that to guide
If I ask
her
each one of my teachers.
application. This take a little bit from each teacher.
I would be the greatest applicant
If
ever.
they had me before, they'd say, this sounds just like Dr. Christie.
Right?
Well, we'll start without
I
Tony.
currently teach, EDU 337.
Yeah. All right, let's take a look at adding three. Oh, I think she might be coming up now. Oh, that's Shannon. Oh, that's right, Shannon. I didn't see Shannon and Troy weren't here.
We're your favorites. We forgot about you losers.
Is Tony anywhere near?
Yeah.
Oh, there she is. Okay.
I don't know why we always split.
All
It's
right,
like we're not really with each other.
let's take a look at
Exactly.
what the Khan Academy, how they want to show students, this is 3rd grade, how to add 3-digit numbers, because now we're going to look at how to add multi-digit numbers. A multi-digit number would be something over 9, has more digits, okay? So 24, 122, and so on. Where is it? This is a bad example. I think it's a bad example. And look at the, and I think Khan Academy does have some good things on there. I remember one time seeing something that surprised me, but it was mostly traditional. That's why I don't advocate it, because it's a very, very traditional. And they're going to talk about things that you may still have some problems with. I know I did until I started teaching this class a lot. But I don't like some of their explanations why they're doing it. Yes?
Are there any things that you like, and this could be up through high school, that you recommend that the traditional approach is sometimes more effective? Or do you think that, you know?
I really don't. I don't think there is a,
I guess I just can't, I have a hard time, like, not that we're high school teachers, but like what I learned in high school, I have no, like, understanding of how that would be, like.
Yeah, I mean, it's almost like when I was doing the thing with my,
Yeah.
my nephew, it's like, yeah, I could do all this, I got through it all, I don't know what any of it meant. Yeah, I don't see a real good, that's just so unnatural too, because
Yeah.
math was not developed that way. Nobody just, there wasn't someone in time that just put numbers on a board, put a little cross and said, I think I'll make that plus, and I think I'll make this and this equal this. It never came out that way. It came out where people were actually doing things with whatever fruit or whatever, they're counting and they're starting to count them so they can get an idea, okay, you know, I need to know how much is in this basket, so now I gotta invent numbers, you know, so then they start inventing numbers, now they can start comparing things. But it was the concrete first and the abstract. When they start adding baskets, they start bringing them together, and they say, well, you know, I don't wanna have to take everyone and just do them like this, maybe I'll just represent it like in a picture. So they probably start with the semi-concrete, making some pictures of representing it, because they were easier than having a whole bunch of baskets of things and bringing them. And then they start saying, okay, well, this is going to mean bring together or something, and then they start representing these big amounts with, you know, well, this symbol will represent this whole amount. In other words, that's the way, and they were very, very bright people that came up with this. That's what they had to do. And so what we do is we turn around for these, regular people, and we try and teach them. We say, oh, let's just skip ahead to this abstract part, and then we just get lost the whole meaning. So the whole purpose for learning is to apply it just in the real world. And so you learn all that stuff in high school. It's like, well, what purpose does that have if I can't apply any of it? So yeah, I don't really see a good, mnemonics can be good, but again, the skill part, like practicing the worksheet, that's okay, but look where it comes into play. Once they understand the concept, like we were just doing, addition is like, or subtraction is like addition, once they understand it, they build it, and they tell you, then, or maybe sometimes you have to tell them, we don't always know how to get them, but then you're ready to do this. Now they understand it, now they're ready to practice and practice. Now they're ready to do the lower levels of balloons. So it comes all at the end, okay? So yeah, I don't really see a good, I haven't, I teach, how to teach math all the way preschool through grade 12, and I don't see any type of, real benefit. I guess I'm gonna take that back. If you wanted to be like an engineer or something, and you just didn't care what any of this stuff meant, you just need to use it to get that degree, eventually you're gonna have to know what it means to apply as an engineer or, some kind of problem. You have to know what those things mean. So you do find out, but you'll find out in college, okay? But, so you can get there faster maybe, but I still think though that's a very, I don't know, just keep everybody, you're always keeping them kind of, think about it. If you're always uneasy, which a lot of math classes are beginning in second and third and fourth, you're always uneasy, why is it like this, why is it like this, and how am I gonna remember this, we're very uneasy. Think about that anxiety that you associate all the time. You're constantly in this anxiety pool, so to speak. And I'm waiting for the teacher to tell me how to do this. So you're constantly in that situation. You're relying on someone external. That's where panic comes into play. When you have to rely, when you feel out of control, you aren't controlling the events. So I can't control the knowledge. I start to get panicky, and I'm in that constant state beginning in second, third, fourth grade with math. Okay. And so that's my association with math, okay? And it just isn't, it's actually unethical, to put people, make them feel uneasy. So anyways, that's what you're kind of doing with them, whereas you could be raising them in where they feel confident, okay, I understand it, therefore I can control it, I can figure things out, like these students, they weren't afraid to answer these questions, and they were coming up with really good things, because they understood it, they would not be panicked, on any type of new problem. They would say, oh, it's a new problem, I'm gonna figure it out, just like they did with the boxes. She didn't tell them how to do it, they just had a problem, and they felt, you could tell they're in an environment where they constantly are figuring things out. Whereas if you went to a traditional first grade class, and you gave them that problem, they would say, okay, well, they'd be sitting there, well, show me how to do it. You're saying, no, you try. You're supposed to teach me. Because they were trained, and that's what we were trained to watch in math class. So that's a long answer to what you said. What you asked there, but I think that's a good question. He'll be on the next test.
What was the question?
Okay, let's look at what Khan Academy does.
We're going to do it two different ways so we really understand what this carrying is all about. So first we'll do it in the more traditional way. We start in the ones place. We say, well, what's 6 plus 8? Well, we know that 6 plus 8 is equal to 14. Is equal to 14. And so when we write it down here in the sum, we could say, well, like the 4 is in the ones place, so it's equal to 4 plus 110. So let's write that 110 in the tens place. And now we focus on the tens place. We have 110 plus 3 tens plus 9 tens. So what's that going to get us? 1 plus 3 plus 9 is equal to 13. Is equal to 13. Now we have to remind ourselves, this is 13 tens. This is 13 tens, or another way of thinking about it, this is 3 tens, this is 3 tens, and 100, and 100. You might say, wait, how does that make sense? Remember, this is in the tens place. When we're adding a 1 10 plus a 3 tens plus 9 tens, we're actually adding 10 plus 30 plus 90, and we're getting 130. And so we're putting the 30, the 3 in the tens place represents the 30. So this is the 3 represents the 30. And then we're placing this 1 in the hundreds place. 10 tens is equal to 100. And now we're adding up the hundreds place. 1 plus 5, 1 plus 5 plus 3 is equal to, let's see, 1 plus 5 is equal to 6 plus 3 is equal to 9. But we have to remind ourselves, this is 900. This is in the hundreds place. So this is actually 100, now when we call the colors the same. So this is actually 100 plus 500 plus 300 plus 300. Let me get the color coding right. Plus 300 is equal to 900. Is equal to 900. That's exactly what we got here. 100 plus 500 plus 300 is equal to 900. And we're done. This is equal to 934.
Okay? All right.
So is that not how we were supposed to teach it?
If your students had done some things prior to that, a lot of things prior to that, that could be a review. But that is not the way to teach it. Okay? In other words, initially, how to teach it or introduce it. Because there's a couple of things in there. I mean, like first off, he started off very early and talked about carrying. What's carrying? What was carried? Nothing was carried. There's nothing physically picked up and carried. Okay, that didn't happen. So now we got this strange word called carrying. Tens place, he's talking about tens place and hundreds place. And for your students, most of them don't understand place value. Like, if you were like me, and I think I said this in yesterday's class about the decimals. Remember I said I didn't know why there were ones and tens. Well, the same thing here. Okay, I was taught this is the ones place, this is the tens place, and I didn't know what any of that meant. Okay, so when he's using it there, there's a danger if they really don't understand place value that they're getting back to that thing saying, okay, tens place, hundreds place. I don't know what it means. Okay, because again, it's all abstract what he's doing up there. Okay, and where the abstract comes into play, you see up there on the board. So that's why I said if he did something prior to it, and that was a review, that would be okay. He's like reminding them, oh, remember the tens place? What's the tens place? Okay? And then he's talking about like 3 tens, which is really good if they understand what 3 tens means. Yes?
So is this where you would use those exploding dots that Lang taught us about?
That she uses that. I don't use the exploding dots. I actually think of that. I mean, that is. I think it's a good strategy. I just don't use that strategy because it's still semi-concrete. I want to use something concrete. Okay, that's what I want you to think about today. I want you to kind of work on how would you get a student, maybe not to do 3 plus 3 digits plus 3 digits, but how are you going to get a student to do multi-digit addition, whether it's 125 plus 48, or 32 plus 19, okay? So how are you going to get them, because we do want them to say 2 and 9. We do want them to look at it that way. But now think about it, if I do this in an abstract way, which is what he was doing there, if I say 2 and 9, if I'm really thinking about this, I'm thinking, no, that's 32 and it's 19. You just pull the 2 off of it and the 9 off. Why can I do that? Can I do that with words too? Can I just say, oh, just take the E off here and the X here, and I'll just make them all a Z? Now, as strange as that looks to us, that's what's happening here to those students. You're pulling something. They see 32 as this. That's this thing. Just like the is TH and E. It's not TH. You can't just pull. You pull that E off, and you changed it. Okay? How am I going to get them to see that I can look at the 2 and 9? Because what he's doing there, that is the goal. That's the end game. Okay? Doing everything abstractly, being able to add it and carry and so to speak like that. Okay? Doing all those things, but do it the way we're going to do it. How are we going to get them there that they're going to understand that? Yes?
So isn't this where I've seen my son come home with worksheets and things like that when they were little, that you have boxes that say 1, 10, 100, 1,000, and then what is that, 32 you have on the board? I can't see. 32. So the 3 is in the 10, and the 2 is in the 1, and so it's in its own little box. And so from there you can tell that that's a 1, and then you can actually draw circles in there if you need to, draw 9 circles or 2 circles, and that's how is that something like that?
Well, you are moving in the right direction.
But that's not how you start?
No, that wouldn't be how not the way I would recommend that you'd start. Yes. I want you to talk about this for, 5-10 minutes and kind of come up with something, and then we'll talk about it. Yes.
So on Monday when you mentioned teaching place value with like the number like sticks in
The base 10 blocks.
Yeah, the base 10 blocks, and I feel like that may be a good place to start because they can start to see 32 as 3 10s and 2 1s, and they'll see 19 as 1 10 and 9 1s, and if you kind of like move those around, you realize that okay, well 2 and 9. I can make 1 whole 10 block, but there's 1 left over.
Mm-hmm. Yeah, so now you're getting more towards where the starting point is. Tony, yours is more in between to getting to where the Khan Academy is. All right, so think about that. Think about the types of problems you would pick, and how you're just design a general, first grade to third grade if you want to go that far. Just a general plan, not an exact lesson, but a general plan like you're talking about right now. Okay? It's going to take about 10 minutes and work on that.
But they understand addition as a concept.
They don't even know what makes sense hundreds, so you have to start with that.
What if like you know how they do it? So if you've already started with base 10 blocks and understand the systems, maybe have like a variety of manipulatives like these base 10 blocks available, and just give them like maybe 3 to see to it. Yeah, with 11 Well, yeah, like numbers that are easier to work with in teens.
Yeah,
How about you do that?
Yeah.
Or like even 19 and 12. So they have to understand here, but it's like smaller, more like in their head frame.
I know they probably, but that's probably harder to do. Instead of doing 125, let's do 48 without 21. That's 15 classes.
What if you do kids in your
Yeah, you know what I'm trying to say though, like, I think the numbers are bad too big, but I think that in one month and
I was gonna say, even if you like, I mean, this is a, you know, if you could combine with like another teacher, like two secondary teachers, and like have them add the amount of students in their class without counting each kid. Because that's like two like real life, well, like, yeah, cause you wanna go in real life, give them context. And while like, these are a context where like, it's not as like relevant to them. Whereas if you give them a relevant example, like it's Valentine's Day and we have two groups of Valentines, or like, you know, like even like you're teaching in February Valentines. You know, Mrs. Christ's class has 31 Valentines and we have 25 Valentines. How many Valentines do we have to get? But that's what he's saying, is to start with the word problems, give them the context for the situation. That's going against what we taught. We always taught, like, you know, okay, this whole carry, like, context of the. Then you can give them the manipulatives to represent the Valentine's in your group. Because like those kids in the first grade video that they like did multiplication. She did good. Like Charlie Pies. She doesn't know. Like sometimes she's like, I just want to kiss your face.
I really like the way that they're all smart, and then you would like to allow these teachers also this is that, and then you can also
Have them explore those first.
place values, it doesn't like add interview stuff, like, so that you need to use them all. And then we play the next block, I'm doing a big block, so I learned and that's what honestly. Oh, yes. And then they, you know what I mean, like, I think that you could explain it to them, but not like make that a test. You know what I'm saying? Yeah.
I don't want to do it though. Just let them explore, because they'll notice those patterns too.
Yeah, like,
Oh, like this and here's that. They're having that.
yeah. And then like it's, you don't have to like, for instance, click the teacher. You don't have to test them for the shot. Because if you put that on that, like, it's not even anymore. Which I remember learning at home. And I hate chunking. What is this? There's only one. There's 500 in it. No, that's why I learned. No, it's not.
I know. Like, I didn't take one language, but you have to learn like different bases. I took 111 and Tri-C, so I saw.
Oh, we ready?
I think so.
Okay. Now, we already got some ideas, and what I always do when I'm thinking about how I'm going to teach something and create a lesson, I always, of course, come back to this, because I know this is where I want to start. So we have the abstract, which the Khan Academy is doing, and they do some nice explanations there, and they say, you know, these are tens and so on, but that's over here. Okay, that's not a place to begin. All right, we have, Tony, yours was over in here with the boxes.
Don't worry, we moved you forward now.
Okay.
Or backwards.
Well, then you came back here into when you started putting in dots and pictures or something like that, and then the exploding dots are in here. Okay? And then Lauren, you moved it over here. So we've got a lot of parts. We just need to kind of put them together. So what are some of your ideas for getting them to be able to do what the Khan Academy did, but with understanding? I'll just. Oh, I'm sorry.
Okay, so,
I didn't think anyone had their hands up.
yeah, we all have the answer. We're smart. We're all the deans listening here. I don't know if you know that or not. It's like required. So, I feel like everyone's on the dean's list. I promise you. I looked at everyone. So we went with the 32 and the 19
Okay.
and said that, okay, so we get our base 10 blocks out. We're assuming they already know that the square is 100, right?
Okay, yeah.
And then the stick is 10 and then the 1. So break the problem up and just do the 2 and the 9 first. So let them get the little tiny cubes and then count them up. They'll notice that they equal 11, so they have to swap them out for
Okay.
a stick and a tiny cube. And so you do another problem, like try to just give them just single numbers from there. And then once they've mastered that, then you can give them the 2, which was the 32 plus 19, and then use the sticks again. So then they'll know they need 3 sticks, 2 cubes, 1 stick, 9 cubes,
Yeah.
and then add them together just like they did with the 2 small numbers, and then that's, you know, put them all together, and that's how they'll equal 1, 2, 3, 4, 5,
Yeah.
5 big sticks, and then 1 little one.
So that's conceptually the concrete way to do it. That's where we want to start, right from there. Okay? Someone else? Yes.
And then I kind of built on that a little bit by saying something about how, like, when you make it abstract, about kind of like how we did with the long division in the other class, making the connections between the base 10 blocks and the equation that's being written.
Yeah, that is essential. What you're saying there is absolutely essential, is making the connection between the two, or else they're going to walk away thinking, I have 2 ways to do this. And one should be informing the other. They should be able to rely on one to do the other, like we were doing with the long division in the other class. Tony, you made a real good point about the swapping. They have to be familiar with these items and how they work, so to speak. And I think we talked about that a little bit, about introducing these, like we're using these initially with like kindergartners and then letting them notice, you know, and so on. So they've got to be familiar with that, because if they aren't and you're passing these out, now you've got another issue going on. They don't know what these things mean, and I'm trying to teach them how to add. All right, so we're going to use the base 10 blocks, because that I can see, that I understand. All right, now let's see here. One thing, we can make it a little bit simpler than what you were saying, what everyone's been saying so far. How can we make it 32 plus 19 is the problem chosen? Can I make it a little bit simpler?
Like 30 plus 10?
Okay.
Is that what you mean by simpler?
That's definitely simpler. That's in the right direction. There's no carrying. There's no trading. Okay, so maybe I'm going to use that prior to the one where we have the trades. Yes.
That's kind of like what I started in the beginning. It depends on how big the numbers are and how I want to do it all the time. But the one that's like 30 plus 19 sounds like if you take 19, maybe make it 20, and then you can add it a little bit easier and then subtract one of them.
Yeah.
But I wouldn't do that with like super hard numbers. Like I probably wouldn't do it with like 100 and some, because then that could get a little confusing.
Actually, that's kind of precedes all that we're going to do right now.
Oh.
Okay, so we are going to get that. Those are called invented strategies. Okay, where prior to what we're going to do right now, we're going to hand out the base 10 blocks. Hand those out. prior to the final rules, algorithm, procedures that we're so familiar with, prior to getting them to do that, prior to all the things we're about to do right now, we let the students represent the numbers with the base 10 blocks. Thank you, Lauren.
Oh no, tens everywhere.
That's a good name for a book.
Tens everywhere. Write a book. We should write a book.
Actually, I mean, that would be a good exercise. Because a lot of times, students will be looking for books about, like, they want to introduce something, and they'll email me, and I'll say, well, I don't know of any book that does that. And we really could just write one. You know, just make a few panels and write it and say, here's my story, and
Hey,
You could write your own book.
your January over here. Birthday episode coming.
Yeah, one at a time, please.
One class, it's not like pickles and farts there, it's just everyone just wants that.
all right, I just gave you a map that helps things along. You probably don't even necessarily need this map. Okay, this is keeping the hundreds and tens and the ones separate, as you probably could guess. It's not very big, unfortunately. I think it should be on a bigger sheet of paper. Okay, so the first thing I want to do, and so this is going back to Shannon, what you were getting into was that I want to use simple problems. I just want the students to get used to using this, and I want them to do it however they want. So maybe before I even give them this, I just say, show me 24, show me 6, okay? So they show me 24, and they show me 6, they don't even need this. Make it 24 and 5, so we don't have one. Okay, so they show me 24, they show me 5, and I could say, okay, now, if you bring them together, how many total blocks do you have? Okay, 24 and 5, in the concrete, say 29. I would say, now, when I bring things together, what is that math? It's addition. Now, when I write that, 4, 5. Okay, or this is the time to introduce, or at least have previously introduced the vertical, so we can align the place values, so to speak. What we're really doing is we're aligning the same types of blocks. Okay? All right, so I would do a few of these, just working with very simple numbers. So let's just say we have 36 and 12, so you have 2 digits in both of them. Okay, and now I'm going to, and I'm letting them do it however they want. Okay, so that's kind of, Shannon, what you were saying. Say, okay, I see it like this, I want to do it like this. You're going to see them do a few things that are going to kind of catch us by surprise. You can even bring in hundreds if you're, in first grade as well, but usually this is the first grade level is just to have 2 digits plus 2 digits. What they typically do is they either put them all together at once, or they put the tens together first and then the ones together. In other words, they go, what we would say, from left to right. They do the tens first, then the ones. Okay, so I'd ask, okay, how did you do it? Some might say, I just brought them all together. Some might say, you don't have to walk around, because they're not going to figure out, be able to tell you what they did. They're just going to say, well, I added them together. So you have to kind of walk around and watch, and you could say, oh, I see that that Grace, you did this here, or even have one of them come to the front and do another problem and say, okay, look at you, you did it this way, did anybody else do it this way? The tens first and then the ones, okay? You can also bring in those where they're going to have to make a trade. So right away you can start bringing those in. So now they suddenly have more than 10 little cubes. And so they add them up, they count up what they are, and you're going to say, okay, what did you do first? You know, can you show us up here? Oh, you made a trade. Why did you make a trade? Because I have 10 and so on. And then that's where exactly what Tony was saying. They got to be familiar with this, with making these trades. Okay? All right? So now all they're doing is you're giving them problems and they're figuring them out in the concrete. And they're just writing the answer up here. So they're representing it. But you see we're on the left side of the board now, concrete. We understand that there's a context for this. We're understanding the concept first. All right, now, maybe as you're talking to them, and they say, like one says, well, I added the, you know, like they come up here and they show adding the tens first and then the ones, okay? And maybe someone just pushes them all together, and then nobody adds maybe the ones first and then the tens. And that's what we do over there. We add the ones first, and so we need that to happen. So if they don't, you could say, oh, is there another way? Is there another way we could do it? You did the tens first. Is there another way we could do it? And someone's going, oh, the ones first. Oh, let's try doing the ones first. So we do the ones first, then the tens. And I want them to practice that procedure because that's what we do here. Okay, so first they're doing however they want to do it. The second thing is we're going to focus on this procedure. We do the ones first, then the tens. And they're going to practice it. The concrete and move into the abstract. Is that okay so far? Okay? Now at some point, you know, they've done 2 or 3 of these. They're adding the ones first, then the tens. Okay, and they get their answer. Now, Rachel, what you said about making the connection, here's the important part. Because right now all they've done is I've written the problem on the board, they've represented it, they've solved it, and they've put it over here. Now's the time you've got to make those connections. And this is really a key part, because if you don't make those connections, the next part they're going to see as being a whole different thing. And that's where I think a lot of teachers, where they kind of lose the students. Because now they start saying, oh, here's what you did this here, and they aren't making the connection enough. So I said, okay, let's start all over. So let's just go to 35 to 14. Okay, because the students can't really remember what it is they did. And they could be using the map I gave you, or they could just, you can see that, you can just see how they're naturally apart. I mean, which group goes with which. And by the way, you see how the students just naturally add the tens to the tens and the ones to the ones. They don't mix them up. Okay? So I'd say, okay, what was the first thing that we did? They say we added the ones together. I say, okay, so we did this. All right, and now here's the attachment. Where are those ones up here? Where are they up here? We have 35 and 24. Okay, and it's the 5 and the 4. Oh, so we brought the 5 and the 4, we added those together, and we got 9. Okay, do you see how I just separated the 5 and the 4? I think that's, Tony, what you were saying about the separation. You have the different sticks and the cubes. They're separated, and they're telling me where the 5 and the 4 is and how I can add them together. Now it's making sense. Okay, why I can separate those numbers. I'd say, okay, what was the next thing you did? We added the 2 there. We added the tens. Okay, so we added the 3 and the 2 together, and we got, or 30 and 20 and got 50, and say, okay, where would that be in my problem here? And there's a 3 and the 2, 3 tens and 2 tens. I have 5 tens, and we got 59. Okay, so making those connect. So I do another problem, exact same way. Okay, so I let them do the problem first. Okay, so they do the problem, and then we go back. They come up with the answer, with the blocks, 58. And then I say, okay, let's start all over, put 27 and 31 back. So let's start all over, say put the 37. I say, what's the first thing that you did? Add the ones together. Okay, how many ones do you have? 8. Where is that up here? It's right here, right here. 7 and 1 is 8. Okay, so do you see where the pattern's starting to build up? I'm starting to get this idea. Then what'd you do? I add the 10s together, 3 and 2, 3 10s and 2 10s gives me 58. And do a third one like that, and then I'm going to say to them, some problem like this, I'm going to reverse it and say, do you think you could do that on paper first, and then, write that problem down, do it in paper, and then use your manipulatives to check it? Okay, and that's where I'll be walking around, and if they really understand this other procedure that we just worked on, that's why it's really important that they really practice this specific way of doing it. They will say, those are 6 little cubes and 1 little cube, that's 7 little cubes, and that's a 10, that's 2 10s, that's 3 10s. And then they would check it. Now you're going to have some that are going to still invent their own procedure, and that's okay. They might say, okay, that's 1 10 and 2 10s, or 1 stick and 2 sticks, 3 sticks and 6 and 1, 7. Okay, 7 little cubes. Okay, they're getting the right answer. That's going to work. All right, so right now, you want to kind of encourage them to do the ones first. Remember we did the ones first? Remember that? That's what you're going to kind of promote. Okay? The next, so that then they check it. So now you've got them going from right to left and doing the ones and the 10s first, and they're doing it abstractly. The next thing would be to give them a problem in the concrete. Represent 27, represent 35. They bring them together. Oh, I can make a trade. How many ones do you have? What can you do? Can you make a trade? Yeah, I can make a trade. Okay, I'm going to make a trade. Okay, so they make that trade. Then we get the answer here. So I'm going to let them do it again however they want at first. They're just getting comfortable with the blocks. Okay, at this point they should be comfortable because they've been using them before, so it's not going to be a lot, but the first part was just getting comfortable with the blocks. Now comes the part where if I'm going to have them do 35, okay, there's my 27 and 35, so I have them put them back. And I'd say, okay, so we do the ones first. So do the ones, and they do all the ones. They say, okay, we've got 12 ones. And I'd say, okay, where is that over here? Okay, it's right here. And we've got 12 ones. This is where I have to be kind of careful. 12 ones, can I make a trade? They say, yeah, I can make a trade. All right, so make that trade and put the trade up here. Okay, so I made the trade, took off the 10, and put the 10 up there. You know why I'm putting it up there? Because we put it up over here when we write it. Okay, they're going to imitate it. So they get that, say, okay, so what happened to those 7 and 5 ones? Where are they at? Well, some of them are here, 10 of them are here, and 2 are here. See, now I'm understanding the 12 is still there. There's no carrying, so to speak. I just made a trade, and I'm putting it up here. Okay? So I have them do that. Do a few problems like that. Just writing the answers down. Okay, so maybe do 3 or 4 problems because I want them to get used to putting the trade up here at the top. Okay? Then, maybe on the 4th problem or so, we would reenact what they just did, and we go step by step. So in this case, we put the 7 and the 5 together. I'd say, where is that over here? And they would say, right here. And I said, okay, you got 12, but what happened with where did we put the 2 1s and the 110? We put the 2 1s here, and the 110 went over here, went at the top above the 2. Okay, you see, I'm tying it together, it's making sense. So where happened to those 7 and 5? What happened to those 12 ones? Yeah, they're right here. Okay, then what'd you do? Well, I added this 110 to this 2 10s to this 3 10s, and I got 6 10s. Okay? And I'll do a few problems just like that. So we solve it, we reenact it, we tie everything together to this, and then we reverse it. So maybe they've done this 3 or 4 times, we've tied them together 3 or 4 or 5 times, and then I'm gonna give them a problem to try in writing first and see how they do. And then check what the manipulative is. So really what we've done is late kindergarten into late first grade, early second grade. Any questions on? There's a video for that. And there also would be, we would just expand it to 3 digits then to do kind of the same thing. Okay? All right. Everybody have a nice weekend, unless I'm seeing you tomorrow. Then I'll tell you tomorrow what that was. You okay today? A few weeks with that. Shit, that must have hurt.
Yeah.